In order to understand linear classifiers a little better, let's review the notion of decision boundary, which is the boundary between positive predictions and negative predictions. Now, let's say that I have taken my data and I trained my linear classifier and every word has 0 weight except for 2 of them. Awesome has weight 1.0 and awful has weight minus 1.5. So what does that mean? That means that the score of any sentence is 1.0 times the number of times the word awesome shows up, minus 1.5 times the number of times the word awful shows up. So let's plot that into a graph, which depends for every sentence the number of awesomes and the number of awfuls. So for example, for the sentence, the sushi was awesome, the food was awesome, but the service was awful. Where do I plot that into a space? Where we're going to have 2 awesomes and 1 awful. So it gets plotted in the 2, 1 point. And then every sentence that I might have in my training data set or in my prediction set might have, say, 3 awfuls and 1 awesome, 3 awesomes and no awfuls, and so on. And I have a data set like this. The classifier that we've trained with the coefficients 1.0 and minus 1.5 will have a decision boundary that corresponds to a line where 1.0 times awesome minus 1.5 times the number of awfuls is equal to 0. Everything below that line has score greater than 0 for any of those points. And every points on the above that line are going to have score less than 0. So for example, take the point 3 awesomes and 0 awfuls. That has a score greater than 0, so we're going to classify that as +1. Similarly to all those points below the line. Now for the points above the line, if you check yourself, you see all of those have negative score. So we're going to label all of those as negative predictions. And so there's that line, everything below the line, positive, everything above the line is negative. That's what makes it a linear classifier, a linear decision boundary, really. Good. So we've seen that with 2 features or 2 coefficients, our decision boundary is really just a line in this 2D plane. Now in general, we might have more coefficients than that. So if you have three features that have non-zero value, non-zero coefficient, then what we really have is a plane that tries to separate the positive points from the negative ones. If you have more than 3 non-zero coefficients, then we're in this higher dimensional space, in high dimensions. And we call that a hyperplane that tries to separate the positives from the negatives. That was a sci-fi reference, by the way. And in general, if you visualize these hyperplanes in lower dimensional space, or if you use more complicated features or shapes, you might have a decision boundary that looks kind of like that squiggly, more complicated line.